Thank you, Professor Muridhar, for that enlightening talk. I would say there has certainly a lot of overlap in the sense that how this paper, how this work kind of came into being was that, again, as similar to all of us, I was also forced into a situation where I was supposed to teach a prototyping course to design students, but it was again locked down during the semester, first half of the semester. And suddenly I had to come up with these strategies to improvise, to facilitate effective learning, despite the fact that all the students were stuck at their homes, and making sure still that they still kind of get the concepts, the understanding, the hands-on experience as much as possible, despite it being the course running in a virtual mode. And so I'll start off with just a little bit of precursor into. I hope my screen is visible if somebody can confirm.
Yes, Richa.
It is visible. Okay. It's fine. Thank you.
Thank you. Okay. So today I'll be talking about a little bit of precursor into why prototyping is an important topic in design, and what are the challenges with virtual modes and what strategies were thought of, proposed, implemented in a course called Prototyping of Interactive Systems here at IIIT Delhi, where I am an assistant professor in the Department of Human-Centered Design. And I also did a small survey where I kind of collected feedback on the said strategies and their efficacy from the students who actually were part of that course, who were registered students of that course. And then we'll see the results and how effective the students at least found the strategies to be as far as the learning efficacy is concerned. So I think it is undoubtedly prototyping is undoubtedly one of the most integral aspect of the design process. Not only it is something that enables a designer or an engineer or any other people who are trying to implement the design thinking process in to get into realizing the ideas, getting them off of their minds into quick mock-ups or even high fidelity prototypes during the process, in order to understand how different interactions would take place with the said idea, for example, and also collect feedback and all of those activities related to the design thinking process. And particularly physical prototypes, the model building process, there has to be a lot of equipment, different kinds of materials are available, and with more and more different kinds of things like acrylic, with MDF, all of these 3D printers becoming cheaper and cheaper by the day. So I think all of these equipment and all of these prototyping techniques, students need to learn as part of the design education in order to have those set of skills when they actually take part in a design thinking or implement a design thinking process in their projects. They know, they are familiar with all of those prototyping processes and they can implement them, right? And it is particularly not only learning the process, but also exploring different materials and different characteristics of those materials, or different, in what cases, in what scenarios this process, X process made me more suited, or Y process made me more suited according to what my design idea is, according to what my budget is, for example. So all of those is part of the prototyping, learning the prototyping processes course, basically. And it also, because it's a course that is taught early on as part of the undergraduate degree, it's something that also, it involves coming up with assignments and projects that not only boosts interest of the students in design itself, but also motivates them into creative thinking and exploring different materials and different ideas and bringing them to reality and feeling good about it, basically. So all of that is part of this kind of a course. And I think it's the same across all institutes, wherever students are taking prototyping of any material, using any material at all. So just a few points in relation to why, as part of design thinking process or design education, students need to learn prototyping. Firstly, as I already have said, that it enables designers to get a better understanding of the user needs, or see if the component will achieve its function or not, if there are moving parts, X, Y, Z. Reducing costly iterations during the design process. So having early mock-ups or prototypes using simple material like cardboard prototyping, for example, or clay modeling, for example, can enable later changes which may be very costly at the 3D printing stage, for example. Right? Building multiple mock-ups with 3D printer, with a high resolution 3D printer may be more expensive as compared to clay or Lego bricks or cardboard, for example. So like a platter of these processes need to be told or communicated to students. Possibility of using use of design experiments and assembly, understanding assembly issues, or understanding what bottlenecks might come if the design goes into mass manufacturing, for example. So all of these, once they explore prototyping in similar material, for example, can help them in understanding manufacturing related bottlenecks, or even assembly related bottlenecks at the very beginning of the design thinking process. And it definitely enables creative exploration, be it form, be it different designs, be it like your expressing your aesthetic language in terms of your design idea. So the challenges with virtual teaching, a very hands-on course such as prototyping to design students in a virtual mode was, of course, that they were not able to access labs and equipment because they were stuck at home. Then accessing or issuing material from the lab was not easy, was not happening. Then even like, how do you make something and then submit those models? How do you make submissions and get your work evaluated for those courses, for the course? Or some like general issues that is like working in groups, things like peer learning, where you are, all students are in a workshop or in a studio and they kind of look at each other's work and kind of learn from each other also. And they have that experience of, working in groups or even experiencing tangible manipulation of material, which is, the core of learning prototyping. How do you actually, because unless just watching tutorials or just looking at videos may not be as helpful in effective learning of manipulating the material as compared to, manipulating the material yourself or working with those material yourself. So all of these issues were there, and I also kind of looked at available literature for this, but because we all know, I think all of us might have at some point during the pandemic tried to look for some guidance, some handbook as teachers, as mentors, as educators, that somebody can tell us what to do basically. But yeah, now once like people did a lot of improvising and they came up with these strategies, now we are like putting it across into the community. But when it all started, I think all of us were, struggling to get our hands on some guidebook or something to help us with. So there's definitely a gap in research that exists in terms of the design pedagogy, where how to incorporate design education and effective learning of design related courses like prototyping or even sketching, drawing, and all of these hands-on courses. How do you actually communicate that in a virtual mode? So I think I was also in that situation, and I was also not able to find a lot of literature or something to guide um, guide me during that process. So I came up with a few strategies which I did implement in the course, and which I would like to share with the audience. So there are a few like two categories of it. So so one was like a set of strategies related to how to design the at-home assignments so that they are at least somewhat effective and at least try to be as effective as if the students were working in the lab. Right. So firstly, because in the challenges also we saw that the challenges also we saw that accessing material or issuing material is one of the biggest challenges in terms of the students being stuck at home. So designing hands-on activities around materials that can be commonly found at home. So for example, in incorporating lo-fi modeling activities using packaging, cartons, like delivery boxes, bubble wrap, or plastic bags, newspapers, etc. Which is like generally, these are the materials which we generally have at home, right? So one of the assignments that I gave in the very beginning of the course, and it was an individual assignment, that to make egg packaging using repurposed corrugated sheets from delivery boxes. And then also we'll come to the submission aspect also, but here it is mentioned because this was again part of that assignment, that how do you submit, once you've made the model, how do you submit that model basically? How do you submit your work? So even like the students, luckily we have we can assume that nowadays everyone has a decent smartphone, and so I kind of banked on that fact. And so everyone had to, click 3 to 5 photos of their models from different angles, and also make a small video of the usage of the egg packaging. Like, how do you open it? You have to, in that video, you had to open it, put the eggs inside, close it, then carry it from point A to point B, maybe in a hall, the room, then again open it, and take out the eggs. And so all of that retrieval and putting the eggs and closing and opening, all of that mechanism was kind of communicated in that video. So,
Professor, sorry to interrupt you. If you could start to wrap up your presentation. Thank you.
yes, sure. Thank you. The other strategy which was utilized was including affordable material. So again, repurposing material which is available at home was one way of doing it. And then the other thing was giving assignments or designing assignments with material which can be made using cheaper materials which is easily available at the nearby stationery shops, or which they can order from Amazon, etc. So another activity was related to clay modeling, which utilize epoxy clay, which is like M-seal, which is what we call M-seal. It's something which is very easily available in India, particularly in all like grocery stores or hardware stores or even stationery shops. So that was also utilized. The second set of strategies was in relation to communicating the learning material, how to communicate the learning material in what way, and how to take submissions basically for assignments. So the access to lab challenge was in a way overcome by so for example, the lab machines which are for example 3D printer or laser cutting machines. So we organized live lab video sessions where the lab assistant and the instructor, myself, we kind of carried the camera around the lab, around the machine, focused on the control panel. We showed the whole process of placing the material, using the control panel, how to start the machine, what precautions to take care of, doing an entire walkthrough of using that particular machine in one class, for example. And then once the model is complete, how to take it out, what to do in terms of cleaning and stuff like that. And so that eventually when the students do come back on campus, they have an idea of where, like, how to use that particular machine which is there in our then again, other things which we did were like video tutorials and video lab tours. So we made small videos of material manipulation or even lab tours, and shared it with the students. So like small video tutorials of mixing the clay, or even scoring cardboard, and how to what are making joints without too much cutting and pasting and all of those things. We made small videos and tutorials and shared it with the students. And again, similar to live lab sessions, we also made like small videos around every equipment in the lab, and we shared it with the students. The third aspect was, of course, the video submission or image-based submission, basically. So, asking the students to make small clips of their work, where they are actually using it or showing the model from all angles, or using, if it is a usable kind of a product, then using it in different ways in order to show how the functionality or the, the movement of the parts is happening and all that. So these are a few examples of the models that the students made. So like the top line where the cardboard packaging is there. The second image is of a card, is of a clay pen stand. The third, we also taught CAD modeling, Fusion 360. So a rendering of that, it's a lamp design. And so by the time kind of around end of March, when the campus again reopened, so our video tutorials and lab tours kind of paid off, and the students had some idea about how to use the laser cutting machine or 3D printing machine, for example. So we kind of bifurcated, brought the students in lab in very small groups because we couldn't crowd it at that time. So as soon as the campus reopened, we asked the students to come in small groups and start working or share their DXF files with us, and we would cut and give them back, and they would assemble and then click photos. So somehow we were trying to manage in that situation, and they came up with very interesting models. So in terms of the evaluation, I kind of composed a set of 10 questions where they had to rate kind of the efficacy of different strategies on a scale of 1 to 5, and the form was circulated with the students of this course, the PIS, Prototyping Interactive Systems, and we received around 174 responses, and the results are were analyzed and looked upon. So this is just one of the tables of the initial like 8 questions, so which were like rating related. So if you see that majority of the ratings are above average, that is more than 3.5 or above, and I will just move to. So there was another question where the students were asked like which online or remote learning strategy you found to be most useful. So like at home hands-on activities received a very good percentage of response. Then live class tutorials, we had live lab tutorials, learning resources and support material which was shared regularly, or video and image based submissions, which was how they submitted their work. And we also, I also did this hall of fame kind of thing after every assignment. So like, because it was a big class of around 200 plus students. So after every assignment and all the submissions, I selected like around 15 best kind of models and this and that. And I would like showcase them in the next class where it's like, okay, these people have made the Hall of Fame this time and something like that. So that kind of kept them motivated. Okay, next time I will make it to the Hall of Fame and my work would be displayed like this.
Is that okay if we wrap up, Professor? It's so just
yeah. So I just have
yes.
Okay, I'll just conclude my. So in conclusion, I think it's just how so the students felt that despite being in a virtual mode, all of these strategies did help them in learning. And the results also show, promising nature of these strategies and in terms of learning efficacy. And in the future also, I think even with the campuses now open, probably we can keep exploring such strategies in offering these courses to, in remote learning situations where, students take up small workshops, etc., with our labs. So that's one of the things that I'm actually currently doing. I did over the summer. So we did offer a prototyping course virtually to school students, actually, and it was a good attendance, and we implemented these strategies itself, and the response was pretty good. And these are just a few glimpses of once the students are back on campus. This is the final project that they made. So we didn't teach them the machines and equipment again. They just, because of those tours, because of those tutorials, they were very much familiar with the equipment and they could just go walk in the lab and make stuff. This was just last month of the course, and they were able to make some interesting models. And thank you for listening. So please visit IIIT Delhi. And we have a beautiful campus here. You can also get in touch with me over email or maps. Thank you.
Thank you.